Okay, to start with, we're having a quick test on identities. Now, there's a real quiz, a homework quiz, in the 15% category, where you have to start with a blank sheet of paper and you have to recreate all of them tomorrow. Okay, so you have to know all of them. So there's Pythagorean, there's inverses, there's etc. But just for a little quick reminder of each kind, up here I have 7 questions. I'd like you to answer these 7 questions. See if you know one thing you could substitute for each of them, except for number 7, where tangent has so many options. I want you to give me 3 different options of what you could put in for number 7. All right, do your best. I'll put it on pause while you finish this. Okay. So we are, oh man, my microphone's crackling again. Okay, the first one, it's a cofunction one, so instead of sine, you should have used cosine. And cosine of, you don't have to say all of this junk again, you just say cosine of theta. So you could replace all of that with cosine of theta. The next one, that's the beginning of one of the major identities, the Pythagorean ones, and it says that, and then it says equals 1. So what could I substitute in for all of that? 1. That's all you had to do. The next one, cotangent squared plus 1. That comes from this one. Sine squared theta plus cosine. The computer is freaking out here. There you go. Equals 1. And then to get cotangent, I need to divide everything by something. If I divide everything by sine, then I'm going to get cotangent. And this one is the cotangent part, and that's 1. 1 plus cotangent is equal to that part. So here's 1 plus cotangent. It's equal to that part there, which is, what's 1 over sine squared? Cosecant squared. Raise your hand if you had that one right. Ooh, most of you. Good. On to the next one, number 4. This is kind of a double one, because at first you substitute in this, which is cosine squared. And then you have 1 over cosine squared, and that turns into what? Secant squared. This one is cosine. Do you get that? Then it's 1 over cosine. And 1 over cosine is secant. Okay, number 5. Cosine of negative theta. That equals cosine of theta. The only question is, is there a negative that sticks to it or not? No. So this is the correct answer without a negative. If I had done it with tangent or sine, then the negative would have stuck and it would have been right here. But it's not tangent or sine. Number 6, secant. If it's just something simple like secant, then you should be thinking inverse. And that's 1 over cosine. And number 7, 3 different things. Well, you can do inverse like that, 1 over cotangent. That's the first of the 3 things. The next one, you could do sine over cosine. And I bet you most of you had that, but who knew the last one that I meant? Yes, sir. You got it. It's the cofunction kind. Cosine or cotangent. I think you meant cotangent. Or pi over 2 minus theta. Okay, who got the 7 out of 7? Ooh, more people than even thought they were. And how about 6 out of 7? Still very respectable. Okay, if you had less than that, then I'd be more worried, and I'd start studying, because tomorrow, quiz on that. All right? All right, yes. Can you replace secant with cosecant squared over... Now, what you're doing there is you're making up a problem that would have an answer of secant. That's not on any of your lists. Oh, I'm sorry. Would you repeat your question? Which problem number? On number 6, yes? Shh. Guys, quiet. Okay, yes, that actually is a correct answer. I just heard you wrong. Cosecant of pi over 2 minus theta is a correct answer to that. You are right. It's not what I was intending, but it's a right answer. You could even do this. Secant is the same as 1 over cosine, right? And there's, oh, wait a minute, there's no negative in there, though. So Yeah, it really wouldn't work so well. I was thinking you could do one of those odd even kind where they throw negatives around, but you'd have to say the answer was the same exact thing as it was. Secant of theta is secant of theta because the negative doesn't stick. But anyway, yes. On the quiz tomorrow, what I'm expecting, this is another possible answer, by the way. Because of the odd even thing. Okay, on the test, it is divided into sections so that this kind of thing won't happen. There'll be a Pythagorean section, which are all using the Pythagorean theorem answer these. And then there's a section that says, so this is just on tomorrow's test. On the big test, the real test in the 85% category, then it's just using these to answer other questions. So it's not a matter of, you can substitute in anything you want, as long as it gets you to the right place. All right. So along those lines, here are some things you should be able to do. This is a very simple one at the beginning, but it brings up an important point. Many of you know that the answer is 30 degrees by now because I've used this example so many times, but how could you figure it out if you didn't know that? Because your calculator cannot help you because there's no calculators in the test. Triangles. Would you agree that this is all students take calc in a positive, a place where sign is positive? Do you get that? Because it's a positive answer right here. So this is a place where sign is positive, which is either there or there. So therefore, there's probably two answers. The only time that there isn't two answers like that I can think of is when the answer is actually right on this line between the two. And in that case, there's only one answer. Okay, but anyway, back to where could it be? It could be here or here. And I draw my little triangle in the easiest place first. And I would say sine is opposite over hypotenuse. So this is 1 over 2. And do you recognize that triangle? 1, 2, and the square root of 3. And then that triangle is known as the which one? 30, 60, 90. And this is the 30-degree angle. All right. What I want you to do right now is refresh your memory on the 30, 60, 90 and the 45, 45. I did that badly. This one's more like the 45, 45. And this is the 30, 60, 90. I'd like you to write out all 4 triangles like that. Remember, the original ones I had you memorize also could be changed so that they were in the unit circle. Now, on the hardest test of the year, you might be expected to remember something like that. So if you had the normal one, like, just tell me, what's the 45, 45, 90 one? 1, 1, square root of 2. But the other one that's just like that, don't say it. I want you to try to remember those numbers. And then this one we just did a second ago, 1, 2, and square root of 3. And then that one's also got another triangle just like it that you'd use if you were in a unit circle. Try to recall those, please. So Mr. S, if it's in the unit circle, what does that mean? So the hypotenuse must be 1. So how do you get this down to just be 1? Divide everything by 2. That is correct. So 2 over 2, which is 1.5, and root 3 over 2. So if you see any of those numbers, you know you're in a 30, 60, 90 triangle, right? All right. And on this one, you divide everything by what? Square root of 2. But you might not even see 1 over the square root of 2. You might, but if you don't, then you might see what? Root 2 over 2. Anytime you see that, it's a hint on what triangle you're in. Okay? All right. So back to this. Cosine squared equals 1/2. Next problem. If I had to do that, I can't start the problem until I get cosine alone to tell what degree it is. I got to get this squared off of there. So I go square root and square root, and then some of you would be like, but Mr. Server, there's no calculator. How am I supposed to figure out what the square root of 1/2 is? I want you to just think. Don't say it. Think for a second about what that really is, and tell me what kind of triangle you must be in. Come on. Raise your hand if you've got it. What am I talking about? Because why? So this is really equal to the square root of 1 over the square root of 2, which is really equal to 1 over the square root of 2. Didn't you just see that seconds ago? In one of those triangles? Uh-huh. That was right here, and it was right there. And so you were in a 45, 45, 90. So it's not too hard to figure out. You must be in a 45-degree triangle then, right? And this is the opposite. Over this is the hypotenuse. Some people have trouble with this. What's bigger, 1 or the square root of 2? Oh, sorry, that would be not opposite. Adjacent. Sorry. Okay. So what's bigger, square root of 2 or 1? Square root of 2, and that makes sense, doesn't it? The hypotenuse is supposed to be bigger than the adjacent side. Okay. All right, next thing. Stuff you should be able to do. You look at this problem. I'll move the screen up here for a second. And you say, I get cosines on both sides. When can I divide by cosine and when can I not? Some of the problems on the test, you could divide by it and it'd be no problem. Say it again. Yes, if it's got the question mark thing above it, then that's a prove question. And they don't even have to have a question mark up there. But if they say prove that this is true, then you would not be allowed to divide both sides by cosine. You're not allowed to do anything to the whole equation. You can only take this side and simplify it, and that side and simplify it, and you can't do anything like multiply everything by cosine or whatever. But if it's a regular problem where they want how many degrees is it, like find theta, solve, then you can divide by cosine. Why is that good? Because then the cosine cancels the cosine, and this is cosine squared over regular cosine. Some kids get stuck on what that means. It's just like this. You remember you can substitute x anytime you want. That's like x squared over x. Doesn't that simplify to just x? So then this simplifies to just what? So cosine of theta equals 2. And now here's the problem with this problem. When can cosine equal 2? Never. Because if you think about the graph of it, what's the highest cosine ever goes to? And what's the lowest it ever goes to? So therefore, if it ever says cosine is 2, you would say, what? Undefined. Okay? Moving on. Wait a minute, make sure I did all 3 of those. Did I do? Yes, I did. Okay. So, patterns you can find. Quadratics. If you see a quadratic, by now I'm hoping I can just write this, and you should be able to factor it. Okay? Try this one, please. 2. No, let's start with a simpler one. Sine squared theta plus 2 sine theta plus 1 equals 0. Factor it. You can't do it this way. Then swap out the signs with just x's. And then do it. This is with training wheels. I can ride my bike, Daddy. But what if we take the training wheels off? Can you go directly to this? Oops. So what'd you get? What should I put in here? +1 and +1, right? And then there's really not much sense in doing both of them because they're going to be exactly the same, right? I mean, if I do this part and I do this part and they come out exactly the same, what's the point? So we don't have to do both of them. So I'm going to do this one, and I say that equals 0. So I'm going to put a little equals 0 right here. So then sine theta equals -1. I want you to actually finish that and tell me how many degrees that is. There's often 2 answers in a question like this. I'm hearing lots of good things. People are thinking, okay, well, and it's a negative, so then I know which quadrant it's in. And then they're like trying to set up the triangle, but it's a weird triangle. Watch what happens. Wouldn't you agree that if its sign's negative, it's got to be here or here? Do you get that? It's in one of these two. Okay then. So if sign's negative, it's down there. So then let's draw one over here. And let's say this is theta. And sine is opposite over hypotenuse. So the opposite side's negative 1 and the hypotenuse side is 1. How could that ever be true? Only if this side was 0. It collapses down. This side right here has to move all the way over here because the side length over there is 0. So it's going straight down. And there's my answer right there. How many degrees is that? 270. If you said the radian answer would be, do you remember where that is? 3 pi over 2. Now, is there more than one answer on this one? No, because if it's right in between the two, that's the kind of situation where you can have only one answer like that then. That's how that can happen. Otherwise, you want to draw the triangle over here, it's just going to collapse down, or sorry, like this. It's just going to collapse down into that same spot right there, and your answer's right there. So it's one answer. All right, difference of squares. Again, you did this in higher algebra. Remember that. So then you should be able to handle this. Nope, not plus. Right? Isn't that a difference of squares? All right. This is a little weird looking, but isn't that a difference? Aren't they both squares? Isn't one squared a perfect square? Because the square root of 1 is 1. Try to factor that once. Write it on your paper. Come on, Schultz. Pick up the pencil. Engage is a different part of your brain. Square root of 1 is 1 and 1. Square root of sine of the fourth is sine squared. Plus a minus. Why would that ever be handy? Any of you recognize something in there? You could replace this with what? Cosine squared. So if this problem had originally been this over cosine squared, you see how that could be handy? I replace with this, and then I turn this into cosine, and then this cancels this, and I'm down to just this. All right. So you need to be able to do difference of squares. I told you that since the beginning. I'm reminding you. All right, and then canceling and a jumble of terms. Canceling is just, some kids still get confused on, can you cancel, can or can't you cancel the cosines in this scenario? No, you cannot. Can you cancel the cosines in this scenario? Yes, you can. All right. Back to my first list there. A jumble of terms often needs to be rearranged. Whenever you end up with a whole bunch of stuff like on the bottom, let's say a 1 plus a sine squared, and then a plus cosine squared, and then minus 2 sine squared, and then maybe a plus 1. Okay. Can you find anything in there that could be rearranged and therefore go together and therefore work really nice? Guy in the green. The reason I do that, it's I know his name. It's just that I don't want to say it on the tape. So anyway, go ahead. What? You could replace that whole thing with 1. You are correct. All right. How about this? What if I put this with that? What would I have? Minus. Do you get how that would be negative 1 sine squared theta or minus sine squared theta? Do you get how you don't get that? That this and this together would make negative 1 sine squared theta? Okay. So then, do you get how if I put this 1 with it, I'd have a 1 minus sine squared? What could I replace that with? A cosine. So if that was handy because there was like a cosine on top that you wanted to get to cancel or something. This answer here would be cosine squared. Anytime you have a squared, you end with a squared. The squareds go with the squareds. Okay. All right. Now, there's one more sheet of stuff that I got to make sure you know. All students take calc. Comes up a lot because you often have multiple kinds of answers. You know, you might have one answer over in quadrant 1, but there's also an answer in quadrant 3 or something. You got to remember, all students take calc. The triangles of doom. There are no calcs on this test, so the triangles are going to be very important. You need to know if I said that there's something that's a triangle that's got sides of 1, 1, and the square root of 2, you got to know what kind of triangle you're in, otherwise you won't survive. Next thing, common denominators. You got to be able to add things like, for instance, this 1 plus x over x. If I had to simplify that, and I told you that x was really tangent, and what could you replace tangent with? Sine over cosine. If you did that, you see how you could end up potentially having to add these two together? Can you add them together right now? No, they don't have a common denominator. So once they have a common denominator, then I can. So what's the thing I replaced 1 with? Cosine over cosine, and then I can add these together, and it would be cosine x plus sine x all over cosine x. And then maybe if we multiply by the reciprocal of this, we can make things cancel. But the main point I'm trying to make here is you have to know how to add common denominators. All right, and another topic here. Fractions in fractions. Again, if you end up with 1 over sine over 1 over cosine, you got to be able to handle that. It's really not that big of a deal. By the way, what does that come out to be? Because it's cosine. Actually, I should say squared. Sorry. I don't know why I do that sometimes. That would be end up being cosine squared over sine squared, because this one comes up and flips. And that's cosine over sine, which is cosine. All right. Then, how many answers are there? There can be problems with one answer. I showed you one of those where it looked like there was going to be 2, but there's only 1. Sometimes there's 2 answers. Sometimes there's 4 answers. Anytime there's a square root going on, when you take the square root of both sides, what should you remember to do? Plus or minus. And that means you end up with 2 equations. One with the plus and one with the minus. You'll end up with 4 answers on that kind. Okay, and then tomorrow is the identity quiz. And you need to know all of them for that. So be ready. Most of you guys got 6 or 7 out of 7 on today's, and I think you'll be fine. So study that for tonight. Now, is there anything new? All I'm asking you to do is, since I was gone, I want you to have time to have asked me questions, and then tomorrow morning, if you wanted to, you can come in for help. So then there'll be no excuses at all when tomorrow I collect a bunch of homework. Got plenty of chances to do it. So I'm not adding anything new, but I am correcting a bunch of stuff tomorrow. So be ready. All right? So there's 2 worksheets, at least, maybe 3. And then there's 1 book assignment at least that's recent, page 460, 1 to 31 odds. Make sure they're all ready to go. Correct. Like we're going to grade it in class tomorrow. Not all of it, but some parts of it. A lot of it. Yes? The book? I think all the answers have been up. If there is one that hasn't been up, it was not up on purpose. We've kind of mostly agreed to put the answers up, but there are some situations where they're not.